Welcome everyone. Today we will deep dive into ServiceNow ITOM Event Management, a core module within the Now platform introduced in earlier releases and enhanced through versions like Quebec in 2021, Vancouver in 2023, and Washington, D.C. in 2024. Its integration with enterprise monitoring tools like SolarWinds Orion platform and how this integration is set up in real environments. Modern IT infrastructures are highly distributed across hybrid environments, leading to a deluge of alerts from various systems and tools, making ServiceNow ITOM Event Management the intelligent command center that ingests, processes, and correlates these events to reduce alert fatigue and accelerate incident resolution. ServiceNow ITOM Event Management acts as a central nervous system for IT operations, designed to ingest events via protocols like REST API, SNMP traps, syslog, and webhooks, then deduplicate, correlate them using AI/ML-based rules and group-related alerts. Key capabilities include event ingestion from diverse sources, deduplication to eliminate redundant alerts, correlation using event rules, alert grouping based on CI relationships, CMDB mapping with identifiers like IP or hostname, and triggering incidents or automation via Flow Designer. Event management works closely with ITSM for incident creation like auto-generating P1 incidents, CMDB, supporting over 1,000 CI classes for enrichment, discovery for population, service mapping for business impact, and the automation engine for remediation. Organizations rarely use a single monitoring tool, often employing a diverse landscape of solutions for different aspects of their infrastructure, such as networks, servers, applications, logs, and cloud metrics in hybrid stacks. Examples include SolarWinds, Orion Platform version 2024.1 for networks and servers with over 300,000 customers, Microsoft SCOM for Windows servers, Dynatrace for full-stack observability with one agent, Splunk for log analytics processing petabytes daily, and AWS CloudWatch for cloud metrics and alarms. SolarWinds, widely used for network devices via NPM, server health via SAM, and applications via APM, claiming 99.9% uptime monitoring, is a prime example of a tool that seamlessly integrates with ServiceNow via REST API or SNMP traps. The high-level integration architecture involves monitoring tools, sending events to ServiceNow via a MyD server, a lightweight Java agent, or direct API like webhooks over HTTPS on port 443. These events are then normalized using transform maps matched to CMDB CIs via the Identification Reconciliation Engine or IRE, ultimately triggering incidents in ITSM or automation workflows via Integration Hub flows. Monitoring tools send events using various methods like REST APIs such as SolarWinds, Orion, Alert History, webhooks, or SNMP traps on UDP 162, ensuring comprehensive data capture from sources like network outages or CPU over 90%. Once events reach ServiceNow, they are normalized by mapping fields like alert severity to criticality levels and matched to configuration items within the CMDB using unique keys like IP addresses, host names, or serial numbers for added context. Setting up this integration requires several prerequisites, including activating the ITOM visibility plugin, com.snc.smi, and ITOM health plugin, populating the CMDB via discovery, and configuring a mid-server version 11.0 or higher with 8 GB RAM recommended. The mid-server, a lightweight Java agent installed on-premises, is crucial for securely polling or pushing data from on-premises monitoring tools to ServiceNow Cloud via ECCQ, handling 10,000 plus events per minute configured in wrapper override.properties. Integration methods include Integration Hub spokes for specific tools like the free SolarWinds Events spoke supporting over 50 actions, custom REST messages to AppNow Table EM event, or generic connectors like SNMP for traps. Configuring event sources involves defining the monitoring tool in system definition, like event sources, new specifying its type like REST, and the URL such as HTTPS, your SolarWinds Orion API for data ingestion. For SolarWinds, this means enabling external node properties in Orion, setting up alert actions to send HTTP post requests to ServiceNow webhooks, focusing on triggers like disk space under 10% or link down events. Mapping fields like SolarWinds Node-ID to CI identifiers, alert message to descriptions, and severity to criticality, ensures accurate data interpretation and proper event processing in ServiceNow. Event rules then transform and normalize incoming data using conditions like source equals SolarWinds and severity 1, setting up alert grouping, assignment to groups like network ops, and further actions. Accurate CI identification using unique keys like serial numbers, IP addresses, or sys class name in the CMDB is vital for effective event correlation and reducing noise through the identification reconciliation engine. Finally, automation can be triggered via Flow Designer upon alert creation, enabling rapid remediation actions like running scripts or orchestration to restart services on conditions like CPU over 95% on 500 plus VMs. Best practices include maintaining a clean CMDB with 95% plus accuracy using CSDM 4.0 model, starting with a few sources and scaling gradually, and continuously tuning rules with alert intelligence for 70 to 90% noise reduction. Use cases range from proactive network outage resolution, detected by SolarWinds correlating with service maps, server overload management like CPU over 95%, to comprehensive hybrid cloud monitoring from AWS CloudWatch EC2 health alerts. In summary, monitoring tools detect issues like network outages or high CPU, and ServiceNow ITOM Event Management correlates and resolves them via CMDB and automation, leading to faster response times and significantly reduced alert noise tracked by ITOM health KPIs like MTTR under 15 minutes. This integration delivers significant benefits, including a 50% faster mean time to resolution and an 80% reduction in alert noise according to ServiceNow benchmarks and the 2023 Forrester study. Thank you for watching.